Good morning. Am I audible? Tell me. Text me. May I know who is King's Code? Is my student? King's Code. Yeah, yes, ma'am. Yes, sir. Chiki, sir. Okay, sir. Okay. Good morning, everyone, ma. Screen is sharing. Text me, ma. Everything is fine. Shivani. Shivani. Okay, da. For you all okay? Okay, sir. Okay, thank you. Okay, today we are going to see that is signal. In last class, we saw about okay, today's topic is signal. Okay, signal and only in analog we can cover. If I have time, I can cover digital signal also. In signal, we saw about. Good morning, everyone. First of all, signal. You know already. We can we can convey information to any person. Okay, to any person without direct communication. We want the signal for if we are not connected in directly, that time we want the signal. Okay, not connected. We are direct. Okay. Yeah. In signal we are having two types of signal, analog and digital. Yeah, in last class I gave some intro. We want three types of in analog signal. Okay, in analog signal we want three properties. One is, may I know what are the three properties we want, fundamental properties in analog signal? In wave we want three properties. What are they? Text me. Bharati, we want to know about that wave. According to these three properties the wave should be created. Anyone? Bharati, Shivani, Raji ma'am, Chiki sir, Priya. Tell me fast. I said in last class. You recall that? Yeah, Raji ma'am, amplitude, frequency, and wavelength. Amplitude, wavelength, and phase also we want actually. Phase. Before that, we want to know about. Wait a minute. These characteristics, these three characteristics. Okay, this wavelength, phase, whatever it is. These three combine each other. These characteristics determines the shape of the wave, how the wave should be formed, in which wave, electromagnetic wave or anything else. Okay, and how it transmits information. This three characteristics or four characteristics is there. Main three is this one. We don't want to learn wavelength because that's simple, but it we can read. Transmit information. Okay, wave, we want to know about wave. Okay, how the sine wave is. The sine wave is the best example for Sine wave is the best example for analog signal. It represents. Okay, listen. We want the time actually. Okay, how many within how many seconds the data should be reached. Time we want. Okay, so like we can take the time here. This is time. In time unit should be seconds. You know already. Then one wave is we have to draw. Wave should be like this. The water in beach we can say that is wave, like this. Okay, song is going on in background, sorry. In temple it's playing. Okay, here listen ma, how much this. Yeah, you just listen. In this wave, I draw some example here. In this wave, from this timeline to this upper wave, height of this wave. Okay, listen. This one wave, we can consider actually wave. We have to know. Listen, this is the timeline, and I am taking the zero as the timeline. Okay, like this one, this fully. This is the one cycle of a wave. Okay, one cycle of a wave. This full wave is one cycle. Okay, understood? It is called one wavelength, I mean one cycle of the wave. Okay, again it's repeating here again the another this one, from this to this is the second cycle. Then again here this one purple color, this is third one. Okay, I'm saying here three cycles are there. Okay, three cycles are there. Here I have to introduce about amplitude. For that I drawn this line. Listen. Before going to amplitude, I would like to introduce time and period. Time and period we can go. Then afterwards we can learn amplitude. Firstly, you want to no. Okay. Time we want the time. Okay, seconds. Second is the unit. Then T. This is unit. This is the symbol. Okay. Okay. Listen. Listen here. One period I said na, one wave, one full complete cycle. Here, one full complete cycle. It is called one period. One period. This is called one period or one cycle, we can say. Okay. We are listening about, I mean, period. Yeah, here given the time taken to complete one full cycle. To complete one full cycle. Okay, one full complete cycle. How much the time it takes, that is called time period. Understood? Shivani? Shivani Priya? Okay, da. Period. What about period? You understood or not? Okay, da. Then how many cycles are there in this time period? Okay, how many cycles are there? Answer me. In this wave, how many cycles? Count and tell. Bharati, how many period is there? Two. Yeah. So total number of, I mean, number of complete cycle, number of complete cycle occurring per second, that is called frequency. Here frequency is 2. Frequency should be measured in hertz. Do you understood? Can you able to understand? Just simply one full complete cycle, how much time takes, that is time period. Then number of complete cycle should be there, no? For some specific time. That number of complete cycles we have to calculate. That is called frequency. If you are not clear with this, then we will use this one in all the amplitude and wherever it is. We want to use all this time period and frequency. Then you will confuse there. Puridada, all understood? Say yes or no? Okay. Shall I move to amplitude? Raji ma'am, Bharati? Yeah, amplitude is nothing but just simply height. Height of the wave. Amplitude is nothing but height of a wave. Here, listen, this is the height of this wave. Okay, in top here, this is called. I said the clue. This is rough. Then this is crest. This is the name. Okay, highest point we can say crest, and lowest point below that, that means in zero, that is rough. Okay, you can remember like this. In highest place we not able to rough anything easily. In lowest place we can rough easily. So the name you don't confuse with this crest and rough. Manipriya, do you understood? Amplitude is just a height of the wave. You have to remember crest and trough. Manipriya, can you able to get my point? Manipriya, are you understood? Okay, here in amplitude, I said the frequency has F, I mean hertz. We can frequency should be measured using hertz. Time period, it should be measured by seconds. In amplitude, there are so many measurable units are there, ma. According to the wave, according to the wave, unit should be change. Okay, like electrical signal, we can use so many waves are there now. Electrical signal, electromagnetic wave, electric wave, then fiber optic wave, everything. In electrical and electronic signal, we are using so many measurable units are there in amplitude, volts, then ampere, yeah, then watts. According to the wave, we can measure like using this unit. Then decibel. Decibel is the question. You can say decibel. Listen here. Analog signal is the continuous and smooth wave. I said in this last class also, just I'm revising. Infinite possible waves. Okay. Infinite, you have to remember. Represented as a sine wave. They are for analog signal, sine wave is the best example. These are the three properties: amplitude, frequency, phase. In analog signal, there are disadvantages to signal degradation over long distance. Example is human voice. Whenever we are talking via call, that time the signal should be analog signal. Okay. Next term, what is the term? Frequency, I thought, and the three things we finished now. Amplitude, frequency, then phase. Frequency, you want to know. Frequency, can you say some examples? Frequency, I said number of waves per second. This is time. This is amplitude. Tell me the example. Frequency. How the frequency should be vary. In in real life example, I can say we are preparing for UGC NET. Am I correct? Say yes or no. Manipriya, we are preparing for UGC NET. Am I correct? Or just listening the class? Tell me, Manipriya. Yes, ma'am. Okay. That is the last reply, or now you said? All others, we all are preparing for UGC NET or not? Tell me. Priya, Shivani, Sneha, Bharati, everyone is ready. I mean, we are moving towards to clear. Nitish sir and then Raji ma'am, Chiki sir. Say yes or no? Yes. Yes. Okay. Just consider the example as same. We are preparing for UGC NET. Actually, I want to give some other example, but why not? We can give this example. I chosen this example by own. Okay. If I mean we are having only total 10 days, last 10 days. We are having last 10 days preparation. Last 10 days preparation is going. Okay. That time, for example, 10 days are there. If we allot 2 days for a subject, 2 days for a subject, how many subject we can finish? Tell me. Tell me fast. We are sleeping, ma'am. Sleeping or something. I am not able to read your text, sir. Okay. 2 days we are allotting for each subject. We have only 10 days. How many subjects we can read? Huh? 10 days, 20 subject. Okay. Okay. Who said, sir? Then if we change the days, I mean within 1 day, how many subjects we can, I mean within 1 day, we have to finish a subject. Then how many subjects we can finish? 30. Okay. Here I'm going to tell, I mean, this frequency and time period is directly, I mean, inversely proportional. Time and frequency is inversely proportional. If we increase the time, if we increase the time, I mean, two period, the frequency is less. If we decrease the time, that time frequency should be high. Okay, wherever I'm drawing this arrow mark, that is decreasing, and this is increasing. Okay, it was directly, sorry, inversely proportional to each other. Frequency and time period is inversely proportional to each other. Okay, this concept you clear na? Frequency and time, why it is inversely proportional? Clear? Frequency? Isha, Revati, can you say? Say yes or no, ma? Shivani, it is inversely proportional to each other. That is the point. Okay? Shivani, shall I move to next topic? Wavelength. Yeah, ma'am said wavelength. We can see the wavelength also here. Wavelength. Yeah, what is the mean of wavelength? Length. Just simply we can say length. What is the which one is, I mean, I'm numbering here, one, two, three. Which wavelength is high? I mean long. Which wavelength is long? Number Revati, first one, second one, and third one. Which wavelength is long? I am asking long. Long. Yeah, long is the correct word. Tell me. Which one is long wavelength here? Two or one or three? Revati or anybody else you can say. Third one. Yeah, simply we can say by seeing you can see. I mean you can say. Listen, here the concept is, before saying the concept, I can go with example. I am walking with my daughter. I am walking with my 5 years old dog, my daughter. Okay. I want to drop her in school, in her school. Dropping in her school. That time I'm doing this only. Yeah. School campus is here. School campus entrance is here. Okay. I want to leave her in her classroom. Okay. Actually, I can walk with a broader foot span. Yeah, foot span. Okay. I mean, leg, I can give that much broader, I can walk. Okay. Then my daughter is too small here. How she will walk with me? I am holding her hand, but I am walking that much speed. My foot is that like this. This is how I can walk now. Can you able to see here? Okay, listen. This is myself. Okay, I am walking this much broader. Okay, how much wavelength is there? One, two, three. Three. Only within three walk I can go reach the classroom. My daughter is holding my hand. I am holding her hand. So he will walk like this fastly. Chick, 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 like tap. Yeah, my daughter is pitter patter their leg like this, but she is doing something. I mean, more wavelength is there. I went within three wavelength, but maybe my doctor should be using 10 wavelength. Okay, this is the concept. I am giving the example. Just concept is whenever both will walk, I mean, within 5 minutes, both will reach the same classroom. Say, here the point is speed remains Constant. S- Constant. Okay. In both cases, other whatever it is, both waves we can say. Then here the question should be in statement type question. If you can tell whatever the frequency I said na, I show in my hand, I did that. If the frequency should be something, then the wavelength should be, you have to answer. If frequency should be high, then wavelength should be long or short. First question, answer. Tell me the concept. Frequency versus wavelength, sir, but I am asking frequency is high. That time wavelength should be short or long. My question is, tell me that LF, HW, you can say like that in text. L is for low, H is for high. Then long wavelength and short wavelength. Text me. I am giving the time. We can take. Students, you can say. What is the answer, ma? Shivani? Wavelength and time period are both inversely proportional to frequency. Yeah, yes, sir. Here, if I am applying low frequency, then answer is Manipriya. I given the example. If it is low frequency, I am walking with the three steps. Then wavelength should be how much my foot will be the distance. Little short or long. Here, my frequency is 3. Then wavelength should be 3 3 frequency. My wavelength, my leg foot span should be long, na? So high. Low frequency, long wavelength. You can go with this. Low frequency, long wavelength. Then, if then, okay. If high frequency is there, here short wavelength will be there. Okay. This is the point, the statement type question they will ask. If low frequency is there, long wavelength we can get. Yeah, while I'm inserting Wi-Fi to my home, that time I asked to that person 2.5 G. It is showing 2.5 G and 5G. I'm asking that person, sir, why it is 2.5 and why it is 5G? He is telling that 2.5 is frequency, ma'am. If you want for long distance, you can use that 2.5 frequency, low frequency. It will give long wavelength. I hope you all understood. Bharati, any confusion? Yeah, here not able to see. Sorry, I am here writing here. Short wavelength. All understood. This is the point. With my foot span, I am explained. I hope you understood. Shall I move? Low. Yeah, yes, sir. Then phase we have to see. Just the timing. Yeah, I have to finish. Yeah, listen. Phase also easy. Just simply you can. Phase is nothing but two different phases. Yeah, we are having much more phases now. One time we are shouting, one time we will smile, one time we will give love to somebody else, we will cry, everything. Different phases. Like that. Here you have to know about different phases in wavelength. Oh, listen. Yes, I didn't draw that. Yeah. Yeah. The position of the wave, you have to remember the position of a wave at a specific point in time. It should be measured in degree or radians. Radius or radians, we can say. Okay, listen. Here we are having some phases like that. This is the 0 degree. Here I can say 90 degree. In protector we are using na protector in geometry box 90 degree. Then again here I am telling we will go with the slide. I added. Yeah, here you listen. 180 degree, then 270 degree here, here, here. Then again in this line, this is 360 degree. This is the different types of phases in a wave. Okay, in one wave, one period or one cycle, so many phases are there, like angriness, sadness. Okay, you remember that just a degree. 0 degree, 90 degree, 180 degree, 270 degree, 360 degree. This is the quater, we can say. Quater. This is off of the wave. Off wave. Off wave is completed now from this to this. This is off. Okay. Here the point is you want to note down, that is that degree phase is indicating, it indicates where the wave is in its cylindrical cyclic cyclical journey. Okay, such as what are the degree we saw? What are the degree? Can you say in off? What is the phase? If we have half wave, what is the phase of that wave? Anyone text me? Answer the question. If we are having half wave, what is the phase of that wave? We have to move up to peak or throw or zero crossing point. Here 0 degree if we are having means that is the start at 0. We are starting at 0. Manipriya, can you say I show now here. This is called in what degree? Half of the wave. In what degree we are crossing? 0 crossing. Yeah. Manipriya, I am asking to you. Can you answer my question? From 0 to from 0 to we are climbing up. We are climbing up towards this. This is 0. We are climbing up to this. So upward to what place? I said this name called. Can you tell me? This is called. I said the name. In a wave, amplitude is there. Highest wave is anyone? This name here. It reaches to. It reaches to. I want this name here. Here I am asking. The peak. Okay, I said that technical term of that peak or highest something. Two term I introduced in a wave. Anyone? I gave the example also. We can rough easily in bottom. Yeah, crest. Sneha, super. I mean, it's reaching crest. Okay, maybe the question should be climbing upward to crest from 0 degree. It's called the zero phase. Then next question, next point, we have to know the sentence. Next degree is 90 degree. What we can say? The wave should be from here to reaching again here. Can you say the sentence? Can you make the sentence? Just simply it reaches its mm, I mean here this is going like this from this point. Not we can draw like this. Just it's reaching. Yeah, now only it's reaching 90 degree here. Wherever I'm dot giving a red color, that is the point. It's reached. So from this, it can be starting and it should reach like this. Okay, here the sentence is maximum positive peak. I'm just giving it is not in slide, so I can write fastly. You listen. 180 degree point is just maybe no, it's not in the slide. You have to note it down. The wave returns to zero again, heading downward. I hope you all understood. So I am writing. Then 270 degree should be the wave reaches its lowest negative. Noted the question. They are giving trough or crest. You have to go with this. This is the key point. You have to notice this one in the question. Okay, that's all. Then phase difference we have to study. Time is there, no? Just listen. Simply, we can say next topic is phase difference. Difference of the phase. Here we can say what is the difference. Yeah, yesterday Kritika watch our live session with the phase difference. We are watching. I noticed that in last class, we are giving the third question answer in live chat, but she is giving second question answer. I noticed in the live session itself, but after the live session only I informed. Maybe I informed to her. Difference of starting. Yeah, we are starting the class. Just simply use listen this one. Here, the degree phase should be different. Degree should wait a minute. Screen is sharing or not? Screen is not sharing. Screen is sharing. Tell me. Okay, ma, sorry. Now it's okay, na? Tell me. In analog signal, we can measure the time gap between two identical waveforms. Okay, here you have to know that is time gap between two identical waveforms. Same waveform is there, time gap you have to mention. Am I audible, Ra? Kekda? Text me, sorry for the disturbance. Just am I audible now? Tell me, ma. Start at the exact same time. They have a phase difference. Listen the second point and first point. Listen. I will finish within 5 minutes. In analog signal measures the time gap between two identical waveforms. Two identical waveforms are there. The time gap between that same identical form. Two identical waveforms are there too, but that time gap should be mentioned. If two waves of the same frequency do not start at here, this is the point, do not start at the exact same time. We can say like this. That time we can calculate the time gap. It tells you how much one signal leads, this is the point, okay, leads start earlier, we are start earlier, or lag starts later than the other. We can say like this, okay. Now you can understood phase difference is nothing but if we start the session at 5 a.m., someone maybe live is going here, but someone is watching here means they are lagging some minus time seconds, 0.01 second, like that. They are lagging, okay. I hope you understood. If difference equal to 0 degree, that is called in phase. If difference is equal to 0 degree, it is called in phase. The two signal starts at same peak at the exact same time. It is called same. This is the sentence. If the two signals starts at the exact same time they given means that is called in phase. Then out phase is there. If difference equal to 90 degree quarter cycle. I said already. Okay. This is the sentence. One wave peaks just as the other crosses zero. If the wave is crossing the zero just from the peak, I mean, one wave peaks just as the other crosses zero. It reaches here. We draw now here. That time that is out of phase. One wave is starting here, one wave is starting from here. Two different phases. This is one, this is two. Then antiphase is there. Antiphase. It is called difference of 180 degree. So it can be given as like perfect mirror image. We can say mirror image because off of the wave now. So off will be the here, off will be that side. Mirror image. Okay. All the things I covered ma. Here one slide I have to tell. Wait a minute. Here simple analog signal in analog signal, simple analog signal is there, composite analog signal is there. In analog signal, I mean simple analog signal, there was two types of periodic signal and non-periodic signal. That is, in simple analog, we cannot be able to broke down that signal. I mean sine wave. We're not able to broken into two or something. It should be fixed, one fixed amplitude, one frequency, and one phase. If we have multiple analog signals in combination like this is called composite. Okay, combining multiple simple sine waves That is called composite analog signal. Here, whatever we are talking now, voice, music, video, that all are in composite signal. Different frequency, different amplitude. Okay, you can expect the composite analog signal as a question. Then periodic signal we are saying now, sine wave should be under the periodic signal. It repeats the same pattern in a fixed measurable period. But non-periodic, not like that. It should be not have to same pattern, random noise or single voice utterance. Then utterance means vocal, vocal sound produced by one person. Hello, I am saying that much now. That is the vocal sound. We are saying that high peak. Hello, like that I am saying means that is the different sound of voice utterance. Then here the Fourier analysis question. This is the question. In composite signal, they can ask Fourier theorem. If they don't want to mention different frequency or amplitude. Where the Fourier theorem is used, you can go with composite analog signal. In if you want in detail, we can see this about Fourier theorem. We don't want to learn the theorem and all. Just know Fourier theorem is in composite analog signal. Okay. Thank you. One thing I will tell in group. Thank you all.